Okay, so thank you very much for having me along today. Thank you everyone else for coming to listen. I hope it's entertaining. I think as Pete did mention, I'm more than happy to try and answer some questions as we go along. So do feel free to ask and I will try and address them. The main topic of today is I would like to share two of my main passions, which are gaming and Xamarin development, and what happened when a project allowed me to combine the two of those together. Before we jump in, I'll do a little bit about myself. I'm a software engineer. I have been for 15 years. Started off in desktop development, mainly with WPF, a little bit of C++ before that. That then migrated along to building some native mobile applications for some clients, and then combination of mobile development and having some XAML knowledge, I ultimately ended up doing Xamarin development and have been doing so for a good few years now. The main focus around what I do is typically functional business applications. So there's never really been an opportunity to unleash a creative side. That is until this project came along, which is a word search that myself and a friend built based entirely within Xamarin.Forms. I think the biggest thing that we're chuffed about is the fact that we've actually finished the side project. So, like I say, it's built in Xamarin.Forms, and the point of being able to utilize, I guess, what Xamarin's offered us, and then ultimately the community built around Xamarin, we've been able to, from I guess a proof of concept, manage to get this out into the store within 5 months. Now, that's no reflection on, I guess, our abilities as developers, but purely all of the functionality that's available to us. And that's part of what I'm hoping to take you through today. And then on top of those figures, we've recently calculated that we actually had 90% of our code is within the shared code project. So if you're familiar with Xamarin.Forms, you've got you can have any number of shared projects. Typically, you start off with one, and then you've got one per the native platform that you're wishing to deploy to. So, like I say, I think 98% of that code was within the shared project, and therefore we've barely had to write any code for each of these platforms. And again, this would have been impossible without the community. I guess a quick caveat on the 5 months part is the concept lived on long before that, and we actually started writing it in Objective-C many years ago. But life happened, and ultimately it didn't get finished. Given that we were sat at home, not really leaving, given lockdown, we thought we'd dust the code off and see if we could actually try and make use of it and finish that project. I guess thankfully, Xcode reported that many issues. So combination of that and ultimately it being written in Objective-C, we decided to try a different tactic. And given I've been working with Xamarin for a while, I thought we'd try to see what we could do. And that was ultimately the proof of concept we did back in February. Now, we're not going to be digging into the source code from that application, I guess for two main reasons. The fact it is technically closed source, but there's a lot more code around it than the kind of the key parts I want to get across today. So I have built a demo application that's largely inspired by a game that my daughters play, which is based on a memory matching game. And as I said before, I'm good at building functional apps, so that's exactly what it does. It works, but it's not pretty. The process of today, we're going to go through adding some of that functionality to actually view how pretty we can make it. So we'll jump in and take a look at the app, and then we can start to get to our first topic. So we've got a simple application and a set of shapes that can be rendered, and you can ultimately match them. Now, when it matches, it just hides them. You get no real positive feedback on that you've achieved something. So, like I say, what we're going to do is we're going to start to apply some of the concepts that we applied in the word search app to this app to then show how you can actually make it feel much more alive. I keep saying game, talking about a game, but typically most of these effects could really be applied to just to standard applications. So the first part of the talk, and actually a lot of this talk is based around animations. And the first stop on that talk is Lottie. For those of you who aren't familiar with Lottie, it's a package, a library that was built and open source by Airbnb so that they could start to show off fancy animations when you're booking your room to stay in. It's focused around rendering After Effects animations. So any creative types that have used After Effects know full well that it's very impressive what you can achieve. Any kind of custom animations, even actual video editing within them. Lottie itself comes with some limitations, but in the grand scheme of things, most of what you can achieve and want to achieve within an app, you should be able to do. On top of being able to achieve things like this, it's ultimately, there's a plugin within After Effects that lets you export them out to a JSON file. And then that JSON file is then rendered natively on the platform itself, meaning that you can embed images, but it's not recommended that you do, and therefore you've got scalability as well. So it's all vector based. I guess the point on it being impressively small is the fact that if you compare it to maybe embedding a video or an animated GIF, then it's much smaller. I think that the animations we're looking at today are maybe 50 kilobytes in size. And for those who, if you're like myself, I tend to have a picture of what I want to achieve, but actually translating that across to something that actually gets rendered even down on paper, I certainly struggle. So I would like to show you. There's a fantastic resource called Lottie Files. Site seems to use a significant amount of energy according to Safari, but as you can see here, these are pre-built animations by artists, designers. A large number of those are free, and then ultimately it comes with paid content as well. So for the purpose of the app, what we were going to do is we're going to apply two animations. We're going to put, I guess, a dynamic background to make it feel a little bit more responsive or just a little alive while we're playing. And then there's also a little trophy animation that'll show when we get all of the tiles matched. You may also notice, actually, when I started out building the demo application, I tried to build my styling around what I could find in terms of animation. Now, it didn't end up rendering that nicely. It wasn't very nice. So I was then pleasantly surprised to discover that not only can you, not only do we have access to all of these pre-built animations, which is fantastic, but then you can actually go in and even edit the colors to match your scheme. Based on whatever the designers have provided for you. I thought there should be an update button somewhere which is not rendering. Now, I have actually gone ahead and done this for us, so we don't have to go through actually getting this to work, because I can't. Oh, there's the update. I think that's updating the speed. Yeah, I thought typically there was one that came here. So that's one animation that we will apply. So let's go ahead and look at the application. So for the purpose of this, I have talked on this topic before, and in the past, it involved writing a fair bit of code. Now, some people have suggested that maybe there was too much code, and actually there'd be a nicer focus on actually explaining the concept. So what you'll see is actually we're going to start uncommenting things, but I'll hopefully guide you through each of these parts. So to start with, we've got a NuGet package, which will be called, we've got a Xamarin.Forms, com.airbnb.xamarin.Forms.Lottie. That's the package that we then ultimately end up adding to all of our projects. Now it comes with support for Xamarin Android and Xamarin iOS as well, if that's all that you're building. And handily, when you add it, it actually adds a README file and shows you all of the vast properties that you can actually set in terms of this. And in fact, there's far more here than I probably actually could do it justice. There is a link on this in the slides, which ultimately shows you all of some examples that you can achieve. Some basic examples of how to use it, and then actually all of the extra more complex parts that you can do. So you can dynamically control the speed of it if you maybe want to add if you've got a time-based element in the game and you want to put a bit of pressure on the player, then you could up that as it's going along. So you can embed images if you really want to, but you run the risk of it not necessarily rendering that nicely if it's scaling. And then you can even respond to click events within the animation, and I think even parts of the animation, or at least frames, to then be able to control other parts. So I mean, even the animation itself could actually be quite a focal point of the game. So for now, based on what we're going to do is we're going to add in an animation view. We need to tell it what we're going to animate. So on that Lottie site, sorry, I didn't want to jump around too much, but there is a way to download it and we get a JSON file out of it. And that's ultimately what we've got here, got a JSON file. We then need to tell it where to find that JSON file. So in this scenario, I've got 2 in each of the platform specific ones. And I think if we look at, as I mentioned, in terms of size, trophy is 48 kilobytes and the background is 42. So if we were rendering images or videos or GIFs, then that would be far, far bigger. And I believe actually performs much worse. For the background, we're going to make it repeat infinitely. So it's going to just keep recycling as it goes around. That's all that you need to do in order to render this. And then the only extra thing on top of that is, as I mentioned, we've got an animation here, which is our trophy animation, and that's going to render in that black pop-up once we've completed the game. Now we don't want that to autoplay, and in order to trigger that, I've had to do it from code behind. So actually, sorry, I should take a step back. On top of the app itself has been actually built around MVVM, so there's no real complex game engine to this. It's all built within, I guess, as the typical app approaches that I'm used to building. Now, if we started to get into more complex applications, then we might need to break that. And I think there's obviously always sensible times to break it. Typically, sometimes performance comes into a bit better if you start just going straight to code behind. But this is not an intense game, so we can build it this way. It also helps quite well when we start to look at some of the other concepts, because we can purely write the code that focuses on that, and it's quite, I hope it's quite easy to follow. So if we just run this up, you should see now we've got a dynamic background, little dots floating around. You can see there's one of the color schemes that I did miss as part of this, but the rest fits in quite nicely. And then this will be a test on my. There we go. Got a little animation to show that we've succeeded. Okay, so that's good. That's given us a little bit of feedback, but we've got a bit of a way to go because this bit's quite clunky. So sadly, I'm going to jump us around again, and we're going to go on to our next part of the talk. So the second part of animations is the animation class itself within Xamarin.Forms. It's, I believe, an amazingly powerful and quite simple API, and that's a rather difficult balance to get right. And we'll go over some examples to hopefully show off this part. So Xamarin.Forms itself comes with a set of pre-built animations. You can animate scale, location, and rotation based on just some extension methods that have been pre-built for you. But then on top of that, it gives you the ability to build your own custom animations, define effectively each frame within that, what's going to change, and ultimately the full set of events that you're going to see visually. So these are two possible animations that you can see here. So as part of building this app, we ended up consuming a large amount of value out of the Xamarin Community Toolkit, which is kind of, it's a curated set of helpful bits of functionality, from validation code to better things like enforcing some async command practices. So they've provided all of that built in, so you don't have to. So as an example, on some platforms, to avoid the double tap on a button when you actually want to say, well, if you start doing something and then block until you finished, that's all pre-built. You don't have to implement it for each event. So as a part of consuming all of that value, then we've committed to giving some value back to the toolkit, and at the moment that's in the form of a set of more complicated pre-built animations than what currently comes with Xamarin.Forms. These are the two that we've built so far as part of what's hoping to go back into Xamarin.Forms, and that's kind of under review, but hoping that's going to come out in the next release, which I believe will be 1.3. The overall plan is to try and match this site. If anyone, I don't know if anyone is familiar, but there is a comprehensive set of fancy animations that a group of people have built. Shows off what you can achieve as, I guess, a group of open source. So I believe last time we counted, there's about 92 animations there, and the plan is try to animate, provide as much as we can to match this into Xamarin.Forms, into the Xamarin Community Toolkit, and ultimately the Maui Community Toolkit, as it will become fairly soon. Let's get it through over that. And I guess it might be a little late now for Hacktoberfest, but it is potentially a perfect opportunity to contribute. The animation is quite easy to translate. It's almost a case of translating what's written in CSS across to the Xamarin.Forms APIs. So that, and obviously the team that managed the toolkit would be more than willing to accept contributions. So if you feel up for that, then please do consider contributing. Okay, so let's go and apply our animations concepts in our application. So as I mentioned before, so the app is built around MVVM. We've got a view model and some tiles within it. I think you can see here. And then on top of that, so those tiles are actually rendered within a flex layout being bindable. That's basically just being able to repeat it based on a set of rules, telling it how to render. And then on top of that, this is where it might become a little bit more complex. So I'm going to try and explain that in detail. Hide that for now because that's the topic of later. So what we could see is we've got a frame that gives us a circular view, and then inside that, then we've got a path that renders the shape. So that there's not too much to that. We've got the handling of the tapping to say whether we're turning it over or turning it back. And that simply, if we jump into the code base, we should see on select tile, it probably looks a bit more complicated than it really needs to be, but at the moment it changes whether it's selected or not, so whether it's face up or face down. At the moment, it waits for half a second just to show you whether it's selected or not. We don't currently see that in the app because as turning off some of these functionality that we're going to now enable, it just currently makes it invisible based on a binding. So if we, basically, if you've got one up, then it leaves that as a current tile. And then ultimately, if you turn a second one up, then it compares it to the current one. If it's a match, then it marks it as guessed, and then it resets the set after a period of time. And then if it's all guessed, then we show our pop-up. So knowing that we've got a few states that we're setting on our tile view model, that's each of the circles that we're rendering, we built a behavior for that. So it's a way of attaching a set of, I don't want to say behavior again, it's defining a bit of functionality that will run based on any change in state on a piece of UI. And we can obviously define that behavior ourselves. So within this, if you're not familiar with behavior, I can give you a brief overview in the fact that you can define what type of UI control you want to attach to, and then we deal with two main events. We get told when we have attached to it, and we get told when we're detaching from it, to make sure that we can tie up and not run the risk of leaking memory anywhere. So a lot of this is all setup code just to make sure that we're keeping track of the control that we're attached against, and then ultimately we want to get access to the view model underneath. Now, at the point of attaching, currently there is no context, so the tile doesn't, the view model has not been provided. The UI is created before it's actually given. The context is rendering for. So again, this just hooks up for that, and then eventually we hook into a property changed event, which will fire when each of our states change. So if you see here, we've got an is guessed and an is selected, and that these will change based on, this will fire the event that we care to check out. So that's this one here, property changed. Okay, hopeful that's given enough background, but if nothing's clear, then please do feel free to let me know. The first point of this animation that we're going to add in is using the pre-built one that I mentioned to start with. So like I say, you can rotate. It will give us ways to rotate around, that's all axes, or you've got X and Y, or you can change the scale to, basically if it ends in 2, then that's what you're going to get, and it'll translate to 2. So you can move it around. And so these ones are pre-built, so it will just let us provide simple parameters in and do all of the complex parts later on. So what we're going to do is we're going to rotate the tile 90 degrees, so it's almost, you can't see it. Then we're going to change the visibility of the shape, so whether we're making it face up or face down, And then once that's happened, then we're going to finish the rotation to take it back to the 0 degrees. That's the first parameter. Second one is just simply the duration. So we're going to do it in 100 milliseconds. Ideally, it's not good to block the user for too long if you're doing an animation, because at the end of the day, they're going to start to become annoyed if it's not letting them finish the job. So if you can get it short enough that it still looks good, that's ideal. I mean, another scenario would actually be able to force cancel it if you wanted to let them do that. That makes the code a little bit more complicated, but it is entirely possible. And then the final part here is whether you're going to use easings or not. Now, I find that they make quite subtle changes, but while they are still quite subtle, they do make a difference in terms of the animation that you're providing. So it's very important that I thoroughly recommend that you do play around with these. There are some posts, some GitHub repos out there where people have built apps that just let you tweak these, so you can actually start to get an understanding of the effect that they have. And I'll make sure that I put a link in to the slides when I do upload this. Right. So now that we've added in our rotation, we'll run that up and see how that works. Currently for the purpose of this talk as well, I'm actually only rendering on a iPhone simulator, purely because it's a bit quicker in terms of building and running. But I do have an Android phone here that I can show it working on if anyone is interested. So we've got a nice little animation there, but still, when you get a success, it just cuts out. That probably is a little bit of a bug in how I'd left the state without showing this animation. Maybe it should have shown for half a second and just disappeared then. But still, I think we can still give it a bit more positive reinforcement to the user that they've actually achieved something. That's going to take me on to the next part of animations, and that's going to be a more complex animation. So there is a class called animation that itself contains a collection of other animations, and you can then define when those are applied in terms of the sequence of events. I believe you can keep nesting these as much as you like. I certainly haven't tried, not had a reason to really try, but given that an animation is a collection of other animations, I guess you could disappear down the rabbit hole quite deeply. So I'm going to leave that off for now. So effectively, once we've built the animation, then in order to apply it, then you commit it. When you commit it, you tell it the owner of it. So, I mean, that doesn't really matter. It doesn't have to be the thing you're animating, but you have these two bits of information allow you to cancel it. So if you're, or at least identify it. So if you, like I say, if you're going to animate for say 5 seconds and you want, if the user can tap it to cancel it, you could cancel animations like so, and then you can apply the frame to cancel off of. I actually thought you had to apply the name, but you don't, so they'll just cancel all animations. So those there, for the purpose of this, we're going to apply a length of half a second. That kind of ties in with just before it's going to disappear anyway, because that's the delay we've got in our show selection. So you'll see that does delay for half a second. This time we're going to spring in our easing. That seems to certainly provides a better effect than a bounce in terms of the rotation. And actually, when I first set out to do this, I always thought the spring would have done the rotation, but actually didn't provide what I think is a nice effect. So that again, that reinforces that you should certainly play with these. I had to hide that based on, this was just simply hiding it based on, because we had that code commenting out, so we're just going to replace that now. So basically what we're doing is we're going to commit it. It's going to take half a second, apply that, and then there is a callback to us to say the animation is finished. What do you want to do? So we're going to then hide our frame just to make sure there's nothing visible. Now, technically, we're going to scale it down to 0, so it wouldn't be visible to the user, but it is still there. I mean, it still is obviously by marking it visible, but sometimes it's just a little clear, nicer to have a clear definition of what's happening. The only other thing that you can do is you can provide a rate into here, which is effectively, I guess, the frame rate of the animation frames. So that's for every 16 milliseconds, it will then be called back in terms of providing what we're going to define here. Might seem a little strange to have written this first, but I'm hoping that now that when we enable these, it should hopefully make a bit more sense. So like I said, animations themselves, we end up adding another animation into it, defining the behavior. But before we do that, we define the starting, I guess, percentage of the length of our duration of the animation. So we're going to start at 0, and we're going to animate. We're going to change the scale for 20% for the first up to the first 20% of that half a second. In order to give a little bit of a, it's not really a pulse, but it's given this idea that it's going to jump up and then shrink right down to nothing. Actually, we're going to animate down a tiny bit just to give it a little bit of a bulge before it jumps back down. So, like I said, we add it, we define the frames. We then say, well, in our animation, we're going to change the scale to the value as called. Each time we're called back, we're going to set this to this value, and that's going to change from 1 down to 0.9 as we go along. So the first time it might call back, it would be 0.99999, slowly until we get down to 0.9 based on 20% of half a second. And then ultimately, we'll jump back up to a scale of 1.2 of the original size, and then right back down to 0. Now, sometimes it'd be very important to make this value match this one, and this one match this one, and so forth. Otherwise, you're going to get you're going to lose the value of an animation because you're going to get a blocky change. Okay. If we now run this up, we should hopefully get a nice bit of visual feedback when we've actually had a match. Here we go. Okay. Now, I think we're making progress. I think it certainly feels like we're giving a bit more feedback to the user. But there's one more concept that I'd like to take everyone through, and this is one that I was actually really quite surprised that was possible within Xamarin.Forms, and that's actually rendering a particle effect. So in terms of when we were building this, my friend Joe, there's two of us who built the app. I built the mobile app, and then Joe built the web end on top of this. He tried to say, is this possible? I didn't believe it was, did a quick Google, and then it turns out that there's a blog post already out there showing how you could achieve something like this. And I think you can see that it does give a very nice effect. For this, we had to use a Xamarin.Forms effect, and that effectively allows you to override some platform specific behavior. So this is actually, I think, where the only real platform specific code came that we ended up writing. That and some issues with audio rendering. So there's a couple of points on that, and there's a link here. This covers the original article that shows off how you could achieve this. It was the idea of being able to render one and leaving it on screen, but ultimately we took it and bent it to be able to achieve this. So let's jump into our, hopefully our final bit of code that we're going to add. And that's just uncommenting one line. No, it's not that simple. So we'll start with iOS because it's the slightly more simple. Let me take a step back. So what we have to do is we have to define an effect. We have to create the class in the platform, the shared code that defines what it is that what we can configure, and then I guess basically what we can override at the platform specific side. So there's some inbuilt Xamarin.Forms stuff that lets you at least inherit some bits to then be able to create it as an effect. For the purpose of this, we've got a couple of properties that simply allow us to define how many particles are going to be emitted, how long they're going to live for, how fast they're going to move, the size of them. So if you ever wanted to dynamically change it, that's, I think, entirely possible. I mean, this is not built to dynamically change it, but it's entirely possible. And then ultimately, we are rendering an image for this. We have to define a name here. That this will be quite important when we get to the platform specific world, and typically it's the namespace plus it's a fully qualified name of the class, effectively. Then what I've also done is then we've got an event here that will be fired from our shared code, and ultimately the platform specific code can hook up to it and react to it when it is raised. And because we're not raising it from here, we're raising it somewhere else, and we have to obviously expose that. I do apologize if there's any background sound at the moment. My daughters are just seeing their grandfather for the first time in a few years. A little bit overexcited. Okay, so now that we've defined, bars in the way. Now that we've defined this effect and we've added it to our code. So before, what we had our frame that rendered the tiles. That was actually inside of a grid, and I've put that the particle effect the level above of the frame. The main reason being is that because we're messing with the sizing of the frame and the visibility of it, that can actually mess with the particle effect purely because it is ultimately rendering controls natively. So as events change here, I mean, if you set this invisible, then you wouldn't even see the particle effects. So because we don't want to cut that short, we've put it up a level, so then that will be allow it to run to its completion. Now that we've defined, we've got an image, we've got a set of particles, that's lifetime speed and scale, we can then jump over to actually seeing how that works on the platform specific side. So as I mentioned, the namespace and naming is the important part. So for some reason, it's then split into two separate parts again. So what we'll see is we've got the namespace with pairs. So that's the namespace that matches what we'd previously defined in the first part of this. And then we've got the particle effect. Now, since writing this, I've started to realize that having too many names of the same thing actually leads to a fair bit of complication. So actually, typically, I may stick platform on the front of that, just so then it's actually easier to know which one you're referring to. It certainly helps with the sanity, that's for sure. So a platform effect. So now that we've defined our routing effect, then we can define how we override it, and that's through the use of the platform effect in iOS. So we can inherit from that, and in a similar way to how a behavior works, it gives us overrides when we're dealing with attaching and detaching again, so we can make sure that we're not going to leak memory, going to unhook from event handlers. But I guess the more critical thing is when we're attaching them, actually what we can do is we can get access to the particle effect in the shared code base, and then we can get that, and then we can hook up to the event that we really care about. So when we eventually trigger the event to fire, we will then get down to be able to actually render our animation. I guess this will be where the key part of the logic comes, and hopefully it's not too scary. We get access to the control, because ultimately we need to know where it is on the screen in order to start rendering something else, to start rendering our stars. Typically, sometimes the control doesn't actually exist, and actually we end up wanting to go to its parent. So there can be times when these can chop and change. So as a bit of safety, you can go with both. Actually, typically, I found that control is more often not there than it is. So if we've got an effect, then we can get out the bits of information that we need. There's a level of inconsistency between how the Android parts and the iOS parts translate some of this bits of information. So ultimately, we've got to do that translation here in the platform specific stuff. So those are just getting the values ready from what we've defined in our XAML. So once we've got that, then we can. There's two parts to doing the particle effect. Ultimately, we need to know how we're going to emit things, and then what we're going to emit, or where we're going to emit from, and what we're going to emit. The how and the what is probably actually more within the cell itself. So you define a layer, and ultimately that's the thing that does the emitting, and then you define what that thing you're emitting looks like. So we grab the bounds from the control that we're attached to, try and make sure we're within the middle of that. And then we're going to emit. Now, typically the shape probably doesn't really matter, because actually we're rendering an image itself. So onto the cell itself, we're going to give it a name, because that then actually lets us later on kill it once we realize it's not going to live forever, because typically if you kick it off, it will just keep emitting. Tell it how many things to spawn to start with. Then we've got I guess a dynamic range of how they're going to emit. So it's between 0 and the size that's been defined. So you get a slight difference there. How quickly to emit them, how long they're going to live for, and then we're going to emit them in a full 360-degree circle. So we've got our layer, we've got a cell. We simply set the cell on the layer, and actually you could in theory have multiple different cells that look differently. You could have different colored stars, you could have different shapes. You can apply as many as you like there, and then we'll add that to the control, because we're dealing with the core animation libraries within iOS, within the Apple specific frameworks now that we're dealing with their animation layer, which is typically always you've got a UI control, and there's always a CA layer underneath that. And then the act of that will actually kick it off, and that will start emitting. Now, because we don't want it to emit forever, what I've done is we then kick off a background task to then wait 100 milliseconds, and then we'll cancel it. And that's by actually basically telling it to stop birthing new cells. So there's that. I know we are running on iOS, but you should see that there's a similarly defined one for Android. There's a slight complication with Android, is that I had to bring in a third-party library. It's not available as a NuGet package. It's just a DLL that's been compiled. That's all in the blog post. It's linked there. And then there is a code base that I will be sharing the link to later on that has all of this pre-built. So that's all there is. This Leonid's Xambind. That's bound to a Leonid, an API that lets you deal with the actual particle effect emission. It's similar in a way. So we've got, again, we're grabbing out the bits that we care about. Then we dealing with just some Android specific stuff to work out where the location is and where we're going to render it. We're going to get access to the image that we care about, because that's as we defined in the before. So if you're familiar with iOS, that's in, I've put it in the Android asset folder. So there's a star. And then on Android, I've been naughty and I've not provided all of the many sizes. I've just provided one just to prove that it works. But in theory, you'd probably want one scaled to each of the relevant different DPIs that devices support. So we get access to the image, and then we work out, create a new particle system, and that's this library that I mentioned. And then you can give it similar things to a range of speed, range of size, where to emit from. And then again, we kick it off and we tell it to stop emitting. A little inconsistency there, that's it's 200 milliseconds. Probably should be 100. I'm not convinced that made much of a difference. So now that we've applied that, we're going to jump over to the final part, and that's actually kicking it off. Now, obviously, it'd be better practice to maybe make sure it exists rather than just going straight and grabbing a first, but we know it's there because we have constructed this ourselves as per that. Oh, and that's the other key point, is the fact that because we've got the frame and the effect we've attached is to the parent grid, then obviously we have to go up a level to get to the parent before we can kick it off. So hopefully you get a little star effect when it completes. Probably wants to be a little delay there to show that we the final particle animation, particle effect. Okay. So that covers, I guess, all of the fancy UI parts that I wanted to show off. Now, given that, there is every good reason to not always render it all the time. It's great that this topic's coming up more and more frequently, and I have to be honest, I don't know enough about it yet, but the little bit that I have started to learn is that there are lots of things that we can do to actually make it our apps more inclusive to more people. Now, obviously, I've shown you how to make things move on the screen, and there are settings, at least on iOS, to say, well, we really shouldn't be doing that on some scenarios, because actually motion can actually cause problems. So while there's no inbuilt way of doing this within Xamarin.Forms yet, I don't know if there will be, we can, in theory, within our code base, we could then actually check to see whether this value is turned on, and if it is, then maybe we shouldn't be rendering these animations. And then on top of that, maybe we could have improved the contrast based on, again, there are more settings under UI accessibility that can tell you no end of detail of what's been set. And in the past, we've also discovered that there are fonts that can actually improve readability, at least for some disorders where it's actually difficult to distinguish certain bits of text. And that's ultimately, I guess, a slight issue with the app that we built, is that we found a font and we fell in love with it. To realize it wouldn't necessarily suit everyone, but we think that probably would suit a fair amount given the styling that we wanted to apply. But we're currently in the process of looking at adding in the ability to revert back to something that would be more readable to in some of these scenarios. I've shown you lots on what can be done visually, and then ultimately, I guess that there were a lot of other packages that we at least used in building our app that I think needed mentioning. I don't know how many people here have done Xamarin development, or at least mobile development, but image asset management can be a right pain in the backside. I think if you're supporting Android and iOS, you're looking at maybe 6-7 different sizes of each image that you would want to render, and that's only considering you're rendering them at one size. If you then talk about making something that scales up to iPad, then you're talking about more sizes then as well. So, and a combination of actually using SVGs for some things, we render flags, and that actually works pretty well. And then there's also a package called Mobile Build Tools that you provide it an image asset, like maybe the top size, and then it can, during build, it will actually scale it to the resolutions that you need, or based on some JSON config. Poly is great for dealing with communication, making it slightly more robust. So my friend, the other guy working on this, lived in London, so at the time when it was allowed out, he went and sat on the tube and then started to bang the app, and it failed miserably. So we had to work out how we would do that, and at least limit the network activity that we needed. Now that's really only down to an install and then a little bit of diagnostics if people opt in. Sharpnado worked well for us because we had some issues with the collection view. Again, I don't know if many people, if you've used Xamarin.Forms, my hope is that you haven't run into issues with collection view, but I know a lot of people have. And ultimately, there are controls provided by the community that have solved that problem. I don't think they were specifically designed to solve that problem, but they do. And then the rest, I guess the rest are fairly self-explanatory. So there's some code that helps not have to write some boilerplate code in terms of property changed events for MVVM. The Xamarin Community Toolkit that I mentioned before, that's helped with actually kicking off animations to start with. That worked out well, and then that kind of triggered the whole talk about providing value back. And then things about in-app billing and store reviews, and playing some video, playing some audio. Obviously, pretty much every app has a database, and then being able to render up plugins, pop-ups. So you show a success message, or I think our store is a pop-up as well. So what's next? We obviously, with our app, we showed how we could make it visually more appealing, but two really great effects, and this should have only shown later, is haptic and audio feedback. Actually getting some, when we added a little musical soundtrack to the app, that actually had quite a big positive feedback. And then actually getting the haptic, the touch feedback, that was also quite beneficial, especially if you can't see what you're selecting. Sometimes that works quite well. And then, as I mentioned before, we found this font, we fell in love with it. I think it made a big impact. And the point is, you could compare from the left to the right to see the difference it makes. The only key point I would need to make is the fact that the vast majority of fonts out in the world are not free, despite them being freely available to download. So it's definitely worth doing your research before you do grab them. Yeah, I think the vast majority of the ones on Dafont are not free. So I would definitely do your research before you jump into using them. Okay, that finishes my talk today. Thank you very much for coming along and listening and watching. I hope you've enjoyed it. I hope you've been able to see how we can make I did say a game to start with, but again, all of these concepts could be applied to an app, maybe with the slight caveat of not applying the particle effect. I'm not sure I can think of a good scenario there, but yes, And I think there are a wide range of possibilities, and I would love to hear whether anyone had applied any of these concepts before in the past or will do in the future. So at the moment, the code is currently here. It's on a branch because there's some work going on based on trying to migrate it to Maui that David Ortonell from Microsoft has been starting to do. So it'd be quite interesting to see how that pans out. But that was based on a slightly different approach, and then I tweaked it to work with shapes rather than images. So I've not pushed that into main yet to not cause any kind of issues with the Maui work. But that but this link will take you straight there. And then as part of the topic here, I've then been starting to try and write a blog series based on each of the concepts applied. So it's taking it from opening Visual Studio through to being able to get to the point that you saw at the end there. That's ongoing at the moment. I think I've released the second one last week, so it's early days. I think we've only got to the data layer yet, but soon it'll suck into the more visual effects. And that itself has its own repository, which I'm trying to keep up to date. So there'll be a branch per post in the series, and then ultimately the main will be the finishing, the end product. Okay, that's everything from me. Thank you very much.
Thank you very much. Sounds really good. Going through quite a lot there.
Yes.
It was good. I've not seen Lottie before.
Yeah, I hadn't seen it before. I was really quite surprised at what you could achieve. Yeah, it's really quite impressive. I mean, it is worth pointing out, so you can't match everything that you can achieve within, say, After Effects. I mean, it will gracefully handle it, it just won't render those parts. So I think actually on our home screen, our logo that animates in, there are some parts of the frames that don't render, but then but we only noticed that by comparing it to the website that we've got that renders the same thing, and it actually renders slightly more detail on the website. But it is very impressive what it can do.
Oh, I like it. Very good. Has anybody got any questions?
Yes, I never thought about accessibility in games so far. Do you have a resource you could share with me as a good entry point to that?
Yes, yeah. There in terms of games, I don't know if I can there, but there's a lot coming. There's Rachel Kang that works for the Xamarin.Forms, a Maui team, that between her and another guy, Shane, they've been pushing a lot of accessibility work within the tooling itself. I guess it's probably not strictly catered towards games themselves, but they are starting to make at least the general concepts more widely understood. So there's this post here. I can put that. And then I think they've started to build an inclusive, that's a link. I won't post that, but that's here anyway. So there's a PDF toolkit that takes you through some of the concepts that you can apply. I mean, if you're doing Xamarin or XAML based work, I know there are some other extensions within for Visual Studio. I know is it Matt Lacey, who builds the Rapid XAML toolkit, has been trying to build in some analyzers that actually help you. So some of it might analyze whether your contrast is high enough in terms of the text that you're putting on screen, and could report warnings based on whether you are actually breaking those rules. But I think a lot of people are still, I guess, learning and trying to build up better exposure. But at least, like I say, Rachel at Microsoft certainly seems to be making a good start to that. I don't know if you can read that. Actually, I'm red-green colorblind, and that is that's very, very difficult.
Yeah, that's awkward. Even without the red, green blue binders.
Does that help to answer?
Yes, definitely. Thank you very much.
Thank you.
Awesome. Any other questions? Silence. That's really good, though. I mean, it forces you to think of mobile development in a different way, and shows you what's possible rather than just. Obviously, I'm a functional programmer as well, so having anything that looks pretty is normally, I can make anything look pretty so long as somebody else has told me what it needs to look like. But yeah, adding in things like animations and stuff, I always like, just to add that little bit of interactivity and makes you feel a little bit better about your app. I like that.
I'm personally just surprised that you can even achieve this in the Xamarin.Forms. I thought you would have had to use some sprite engine or something like that to develop what you've developed. So I'm just blown away by it.
Thanks. Yeah, I was surprised, and like I said, yeah, as Peter said as well, I've mainly I've always assumed that Xamarin.Forms worked well for, I guess, kind of business apps, but then I guess that's the only real reason I've used it. So this was a nice way of actually getting exposure to that kind of thing. There are, if you want to do more complex stuff, like there was a guy built as Flappy Bird's clone in Xamarin. Well, I guess it was Skia really, but he had to then kind of build his own sprite engine for stuff like that. So I guess if you're dealing with more complex elements, I guess maybe moving closer to a game like Flappy Bird or others like that, then that you probably would need to still move towards a kind of game engine.
I didn't think Xamarin.Forms. I thought Xamarin.Forms was purely a business product for generating vanilla forms, not what you've done here, which is pretty surprising.
Yeah, thank you. Yeah, I would recommend trying to play around and see what's possible. I mean, it is surprising. I've got some fun bits planned for the next thing, but that will likely be a sprite-based game.
Oh yeah. What was the bit that you mentioned that there's no NuGet package available for something? You need to include a pre-built DLL. At that point, I was like scared. Like, wow, you like living the edge. Just download the DLL from the internet.
So, sorry, no, I didn't download a DLL from the internet. Let's see if we can find the post. There is another, there's a Xamarin project online that on GitHub, someone's provided the binding libraries for the Android way of potentially doing this particle effect. Now, I mean, you could download his DLL, but ultimately I just grabbed his code and compiled my own DLL.
Oh yeah, that's not really as dangerous.
No, there is just there's no available package for it, so you've just got to do that work yourself.
Yeah, right.
Cool stuff. Any more questions? I mean, we spoke just before this about Maui, and you say you tried that and it's a mess at the minute.
Certainly, my experiences haven't gone particularly smoothly. I've not had the last two previews, if I'm honest. I think I can't remember, was it preview 6 or 7? I just a file new, and you couldn't actually do anything. Couldn't compile it or run it. I think there's still been a lot of work, kind of getting the workflows right, but it's ultimately it's been delayed for a reason, and it's certainly far from being ready. So yeah, I don't know when it's a difficult one because it's now, I guess, would be a good time to get involved and maybe start writing content because it's so young. But I don't know if it's still too young to be able to get that content right and not have to deal with all the pain of fixing up issues that come with the fact that it's preview. But it does look like eventually it will solve a lot of the pain.
Very good. Well, I'm going to stop YouTube at this point. So thank you very much for coming along. Don't forget to come to next month's .NET Knots, and also check out Knots IoT and Tech Days and stuff.